I present to you the paper entitled The Interplay of Modal Dispersion with Nonlinear Impairments on More Division Multiplex Fibers. As of today, more people and devices are getting connected to the internet, which means that the demands for data is increasing every year, almost the factor of 100 after every 10 years. But we know that the capacity of single mode fibers is being impacted by nonlinearity, so it means that we must find solutions that will help us meet these demands, these increasing demands. But how do we increase the capacity? Do we increase more fibers? Do we increase more number of channels? What about the simulation? It becomes complicated as more channel increases, more fibers increases. One of the solutions which we can probably debate about is space division multiplexing, which exists in form of multimode fibers, multi-core fibers, or fibers as bundles, which can help us meet these demands. But the problem again is that while this technology will meet the demands, these fibers will again be impacted by nonlinearities. So we must find solutions on how to combat these nonlinear impairments. One of the solutions which is still under being studied is that we can use the linear effects, for example, it's modal dispersion and strong coupling to fight the nonlinear effects. So in our study, we realized that we can use modal dispersion to combat XPM, which is the dominant nonlinearity in high capacity optical fiber systems. So we came up with a model. For example, we used the scenario of 2 channels previously, and then this model can be extended to several channels. So if in a 2-channel scenario with an ultra long span length, then you can find that the variance of XPM can be calculated by the formula shown on the poster. So it means that this formula is dependent on the attenuation and the channel spacing and the modal dispersion value. So when we ran out the simulation, we found out that when we allow a high value of modal dispersion in the optical fibers, then we found that the XPM reduced until a certain amount. So for example, when you compare the single mode to the case where I had six modes, we found that in single mode, the variance of XPM could reduce to at least 1.25 dB, while in 6 modes, the variance could reduce to almost by 4.3 dB. So it shows that the more we have the number of modes, the more the variance of XPM reduces. So we can use this as an advantage, allow more dispersion in the optical fiber system to combat the nonlinearities. So at this case, we also meet the demand. So we meet the increasing demands, and we also find a way how to fight the nonlinearities. Thank you for listening, and should you have any question, don't hesitate to reach me via email on my email address as shown on the poster.